This is the second part of chapter 2.1. If you just got done watching the video, you just finished the chart that you see below. Theirs is a little bit nicer than mine, but that's because they didn't have to handwrite it. So they cheated. We're getting into grouped frequency distribution. Now you can have just regular frequency distributions. Those are where you only have one number for each category. Grouped is used when you have a large range of data. So what I mean by that is the difference between your lowest number and your highest number. You would use a grouped frequency distribution. Those smallest and largest values are called a lower and upper class limits. Okay. Class boundaries are the things that separate the classes. So these are the values that would be rounded to the lower and upper class limits, which we'll explain in a second. Your width, the width of each class, I'll show you how to calculate that. You can find that it's basically how many numbers are in each class. And you can find that by subtracting your lower class limits, successive ones, meaning one right after another, your upper class limits, or your upper and lower class boundaries. So a few different ways of doing that, but basically think of it as how many numbers are in each class. That's your class width. The midpoint is calculated by averaging your upper and lower class limits. Some rules for grouped frequency distribution. You should usually have somewhere between 5 and 20. Reason you don't want to have less than 5 is if you only need 3 or 4, you probably shouldn't use a group. You should have them all separated. Having more than 20, now you're getting kind of ridiculous. You're getting so many groups that you really can't get an accurate picture of what the data is showing. Your class width should be an odd number. Now, this isn't a must. It makes things a little bit neater, meaning your midpoint won't be a decimal, but it's really just kind of something you're doing more as a preference, not necessarily a requirement. The way you can change that is by changing how many classes you have. So if having 6 classes gives you an even number of class width, you can maybe move it up to 7 or 8 or 9 classes, would then give you an odd number. Your classes must be mutually exclusive. What that means is there's no overlapping between 2 consecutive classes, or any classes for that matter, but you really shouldn't run into anything except for successive classes. So you can't overlap. Okay? They must be continuous. So not only can they not overlap, but you can't have gaps either. Classes must be exhaustive, meaning you got to cover all the data. Okay, you can't leave an outlier like a really high number or a really low number. You can't just say, nah, that makes things difficult, we're just going to leave it out. Okay, you got to get all the data. And your classes must be equal with the exception of open-ended, meaning your last class may be a number and, okay, if we're talking about ages, ages may be grouped. Anybody aged from 0 to 10 years old, from 11 to 20, 21 to 20, 21 to 30, 31 to 40, and so on and so on. And then at some point you may say anybody 80 or older. That's open-ended, meaning anybody 80 years old and on up. Now, that obviously covers more than the other classes. The other classes were only 10 big. This one is much larger. But when the amount of people in that class is so small that you don't want to do 80 to 90, 90 to 100, 100 to 110, and so on. So you may just say 80 to 90. That's called open-ended. The example we are starting is on page 41. So if you want to go to page 41, you can see all the data. The data you will see is this. So this won't be up very long, but this is the data that we're going to be using. Okay. Making one of these. This is very similar to your categorical. So, where's my mouse? Oh, let me turn this on first. There we go. Why isn't it working? My battery's dead. Let me pause you for a second. Okay, we're back. Sorry, my battery died. So we are again going to make a table. Your table headers will be a little bit different. So we still will have 4. This time the 5th one would actually again be percent if you want, but we're not going to do that. So here they are. First one is class limits. Your second one is your class boundaries. Third one again is tally. And then you have your frequency. Ooh, it's a bad cue. Okay. In order to figure out your class limits, what you want to do is you want to actually figure out how wide should each class be. So to do that, you want to find your highest value and your lowest value. Now, if you look at the numbers on page 41, your highest value is 134. Your lowest value is 100. So we want to find our range. Okay. We're short. We're just going to say, what does our range equal, or R equal? So we take 134 minus 100, and you get a range of 34. Now we come to the point where we say, how many classes are we going to have? Sometimes in the book they will tell you break it up into 5 classes. Sometimes on the test I'll tell you. Or you will arbitrarily pick a number. What that means is kind of out of thin air, but usually there's a reason why you pick the number that you do. We want to get as close to dividing by a number to get a whole number as we can. Now, you can't divide by 2 because you want more than 2 classes. Okay? Remember, 5 to 20 classes is what you're looking for. So if we divide by 5, we'd have a range of approximately 7. What they decided to do is, let's divide that 34. We're going to split it up into 7 different classes. So 34 divided by 7 gives us 4.9. Now, you don't want to use a decimal for this. It just becomes a pain in the butt. You don't want to do it. So always round it up to the nearest whole number. Okay? So we're looking at a class width of 5. So that was our class width. I probably should have put this part down here. Class width is 34 divided by 7, which gives you 4.9, which is rounded to 5. So actually, in your notes, I think I would tell you to leave it this. If not, that's fine. That's totally up to you. So our class width, there it is. So let's go back. So our width is 5. So our limits have to start at your lowest. So what was our lowest? Remember, our lowest number was 100. If you want to, what I would do is just go ahead and put the lower limits for each class. Remember, you have 7 of them. You could go ahead and put your upper boundary right here. Anybody know what it would be? You're probably saying a width of 5, so it should be 105, right? Actually, if you go to 105, count how many that is. 100, 101, 102, 103, 104, 105, that's actually 6 numbers. So it's a little bit, it throws you off a little bit. You're not actually going up to 105, you're actually going up to 104. So the easy way is just go 100 plus 5, 105, 110, 115, 120, 125. It's 1, 2, 3, 4, 5, 6, 130. These goes to 104. It's one less than this one. So this one has to go to 109, one less than that one. 114, 119, you get the picture. 124, 129, and 134. Now, what are your boundaries? This is something that you were quizzed on today. Your boundaries, remember, are the numbers that would round up. So how far, what's the smallest number that would be rounded up to 100? Hopefully most of you are saying that would be 99.5. What's the biggest number that would be rounded down to 104? Remember we talked about this actually means 104.49 repeating forever. But we don't want to write 0.49 repeating, so we just write 105. Everybody who deals with these things understands that we're talking about every number up to 104.5, but not including it. So once you hit this number, it's actually your next one. Okay? So these aren't overlapping. This 104.5 does not go in this group. It goes right here. When we're tallying, that's what we're talking about when we're tallying. So this is 109.5. This is 109.5 up to 114.5. This is 114.5 up to 119.5. 19.5, 124.5, so on. And then we go ahead and tally. So we go through all our data and we tally. Where would 112 fit? Right here. Where would 100 fit? Right here. And we keep going through these. Be back in a second. My computer's freezing. So my computer froze on me and I can't write it anymore. So what I'm going to do is use the slides to finish this up. Where we were at was figuring out your range. Remember your high minus your low gave you 34. Your width was 34 divided by 7, which rounded to 5. There's your rounding rule, always round up with the remainder. And then we had our limits, and we started with this. So the frequency was, we did a tally. They leave that out, that tally column out. And the frequency was, hopefully when you went through, you got 2, 8, 8, 18, 13, 7, 1, and 1. The last column is something we will use occasionally. What it's called is a cumulative frequency. Cumulative means how many have appeared before this class, before each category. So how many numbers have appeared in or before 100 to 104? The answer is 2. How many have appeared in 105 to 109 or below? Well, 8 appeared in 105, and there were 2 in the one before. So 8 plus 2, that's 10. How many have appeared in the 110 to 114 class? 18, plus the 10 that appeared before it. Your cumulative is 28. Another 13 is 41. Another 7 is 48. Then we get down to 125 to 129, another 1, and another 1. So that is your group frequency distribution. Your cumulative frequency column, I don't need you to put that in there right now. A couple of them, your book may ask for it on your assignment. You do not have to do that column. Okay. The percent is also something that we do not have to do right now. We may use it a little bit later when we get into certain graphs. Hope you have a good night. Don't forget to upload your notes, and we will see you tomorrow.